Okay, welcome back to Mr. Hassan's Maths channel. I'm now going to answer question number 7 from the C3 Edexcel June 2013 pure mathematics or core mathematics paper. This question is about functions and graphs. And here we have a question which tells us about function f, which has a domain of -2 for x between -2 and 6. And it's linear from -2, 10 to 2, 0. And from 2, 0 to 6, 4. Okay, so from -2, 10, which is this point over here. This is where it starts from the graph, -2, 10. And then it goes down to 2, 0. And then it changes, the function changes like a piecewise function. So its rule changes from 2 to 6. It suddenly has a positive gradient, and that goes up to 6, 4. Okay, so this is the point 6, 4. This is the point -2, 10. -2 and 10. Okay, now a sketch of the graph of y equals f of x is shown in figure 1. So this is y equals f of x. Now, the question tells us to write down the range of the function f. Now, the range of a function is all the output values, all the y values that it has. Now, this has got a restricted domain. It's from -2 to 6. So the output values will go from, as you can see here very clearly, I'll just put these arrows in there, from this point here, from the y value from 0 all the way up to 10. That's where it stops. So they start from 0 and they go all the way up to 10. So you can see that that's the range of this function. That's the lowest it goes, and that's the highest it goes. So it's like, from all the y values it can take. So the lowest it ever goes is 0, 0 on the y-axis, and the highest it ever goes is 10. So we can see that the range of this function, okay, we can say f of x is between 10 and 0. So that's the answer to that part of the question there. Okay, f of x is between 0 and 10, including 0 and including 10. I have to put the equal sign there as well because they are included in this, because it tells us that -2 is included in the domain, therefore 10 is included in the range, and 6 is included in the domain here, and therefore so is this point, and it reaches 2, 0, so it reaches 0 here. Okay, so that's part A. That's part A. Now part B says find f0. Now what does that mean? Well, that means you've got to find what f0 is and substitute it inside the function f. Okay, now we don't have an equation for function f. So how do we find f0? Okay, how do we find f0? So we see this is the function y equals f of x. Y equals f of x. So f0 is when you replace the x with 0. When you replace the x with 0, that's what f0 is. Now when you replace the x with 0, basically you see where the line cuts the y-axis. Where it cuts the y-axis is when x equals 0. So this value of y is what f0 is. So this is the value f0. This is what you get out of function f when you replace the x with 0. So we got to find the value of this particular point, and we can do that quite easily on this without we could actually find the equation of the line and do it. Okay, but there's an easier way of doing it, which is by simply using similar triangles. So I know, for example, you've got this big triangle here from -2 to 2 and from 0 to 10. And you've got this small triangle here from 0 to this point, which we have to find, and from 0 to 2. So if I think about these two triangles, I've got like a big triangle, and I got a smaller triangle, which is actually similar to it. They're similar triangles because they share the same angle here, and they share the same angle there. So they're similar triangles. Okay, we can see very clearly that the ratio of the sides, this is from -2 to 2, which is 2. Oops. This is 2, and this is from, -2 to 2, which is 4. Okay, that's the big triangle. This is 4, and this is from 0 to 2, which is 2. And this is from 0 to 10, which is 10. And this is from 0 to what we have to find. Let's call that y. So we can see by similarity, this is going to be a half of that, okay? Because this is a half of that. So we can see y is equal to 5. If you want to set it up, you can say y over 10 is equal to 2 over 4. So y is equal to 2 over 4, which is a half of 10, which is 5. So I know that that distance is 5, so f0 is equal to 5. I know f0 is equal to 5. But that's not my answer. It says find f0. So you got to find what happens when you put x equals 5 into this function. So you've got to substitute x equals 5 into this function here. So when you put x equals 5 into this function, you see what it hits us. So we're going to see now this area here. So x equals 5, let's say it's around here. And we need to find what the y value is at that point. Okay, we need to find the y value is when x equals 5. So that's x equals 5. And we need to find this value here. Let's call this y, y1. That was y. Let's call this y1. Okay, so I know that this distance is 3. Okay, and I'm going to compare it to the big triangle. Okay, I know that this distance here, this is 6, 4. So that must be 4. And that distance must also be 4. So we can see that this must be 3 as well. Okay, because you've got two triangles. You've got one triangle which has a side of 3, and this side which you have to find, and the other one we got the side of 4, and this is 4. So these two sides are equal. So these two sides must also be equal with each other because they're similar triangles again. So you got something like this and something like that. This is 4 and this is 4. This is 3, and this is what we're trying to find. So this must also be 3, and we can just you say y over 4 if you wanted to show it. Y1 over 4 is equal to 3 over 4. So y is going to be 3. The 4s will cancel. So we can see that the answer to this question is 3. Okay, so there's the answer to part B. Quite a simple question there. All right, I have to think and use similarity. You could have found the equation of this curve, of this line using these points and worked out where it hit the y-axis when x equals 0. And you could have found the equation of this line as well if you wanted to as well and done the same thing. You could have found the equation of this line and put x equals 5 into the equation, and you could have then found what y is. But I think this is a bit easier to deal with than finding the equation of the lines. Okay, so there's part A and B done. Now I'm going to move on to part C. Now part C says the function g is defined by g of x equals 4 plus 3x over 5 minus x, where x is an element of the real numbers and x does not equal 5. Find the inverse of gx. So what we have to do here is, first of all, when we find the inverse of a function, we replace the g of x with y. So y equals 4 plus 3x over 5 minus x. And the second thing is we swap the x and the y over. We just swap them around. So whenever you see an x, you call it y. Whenever you see a y, you call it x. You know, at the moment, we haven't actually rearranged the formula. We just replaced the x for a y and a y for an x, because in an inverse function, that's exactly what we're doing. We're making y x and x y. Okay, we're reflecting it in the line y equals x when we find the inverse function. So the next thing we have to do is make y the subject of this formula, and then the form what we get in the end will be the inverse. So we have to get rid of the fraction, multiply both sides by 5 minus y. So you have x times 5 minus y equals 4 plus 3y. And then we can expand the bracket. So we have 5x minus xy equals 4 plus 3y. And now what we can do is we can bring the y's on one side. I'll bring the y's on this side so they stay positive. So you have 5x minus 4 equals, that will be x, y plus 3y, adding xy to both sides. Now I can take the y's as common, because I want to make y the subject here, remember? So I'm bringing the y's together. So I'm going to make y the subject. So I'll take out y as common. So this is 5x minus 4. And this is y times x plus 3. And then I can say divide both sides by x plus 3. So we end up with y equals 5x minus 4 over x plus 3. So we can say the inverse function of g of x is equal to 5x minus 4 over x plus 3. Now, that is the answer. However, when they ask you to find the inverse of a function, it's always good to state the domain of the function that you found. Okay, even if they don't ask you to, it's always good practice. And some questions they do actually require that. So here we got to think about what the what the domain of this function is, the inverse. Okay, now there's no restrictions on the original function. It says x is all real numbers and x cannot equal 5. So that means, you know, we don't have any kind of restrictions in terms of like, you know, x is greater than a certain number or less than a certain number. They've allowed x to be everything, and of course x can't equal 5, because when x equals 5, this is undefined. So similarly, we can see for this, you're going to have the same situation. It will be x equals all real numbers, except for x cannot equal -3, because that's what it's going to be undefined for. Okay, when you put -3, you have a 0 in the denominator, it will be undefined. So we should state this after we found the inverse. If the domain had been restricted further, like for example, x is greater than 5, then we would have to then think about what this graph looks like with the restricted domain, and then the range of this graph would therefore be the inverse of this graph. Okay, because if there was a restriction here, then of course that would cause this to be different. Okay, it wouldn't have the same domain as it would have if this was restricted. So because there's no restriction apart from the natural restriction that it has to be there, that x can't equal 5, therefore this will have no other restriction apart from its restriction that x cannot be -3, because x is -3, this is undefined. So that's the answer to that question, part C. Now for part D. Now this was actually the question that I was asked about by my student. He asked me to answer this question. So, you know, this is actually the question he asked, but for completeness sake, I did decide to go through the whole question. I'll probably put a timestamp on the video so he can see the question from this point. Anyway, so it says, solve the equation g of x, g f x equals 16. Now, we could do this in different ways. And we don't have the equation of fx, and fx is actually a piecewise function, so it's different in different parts. So it's kind of a bit complicated to do it in a particular way, like, you know, finding the equation of f of x. We'll have two different graphs, and we'll have to fluff around with two different graphs. So there's a few ways we could do it. Now, one of the ways we could do it, okay, is using the fact that we know the inverse function. So I'm going to take the inverse function that we found, which is 5x minus 4 over x plus 3. 5x minus 4 over x plus 3. So we got the inverse function is equal to 5x minus 4 over x plus 3. And we know that x is all real numbers, and x cannot equal -3. Okay, so that's the inverse function. Now, we could do it in one way where we basically do the following. G of fx equals 16. Now, one way is we want to find a way to get rid of this g, okay, g of fx. Okay, so what we could do is we could do the inverse g of both sides of this equation. Okay, so I've got to take the inverse g of this side and the inverse g of this side. Now, if you take the inverse g of g, they cancel each other out. Composite function of the inverse and the original, they cancel each other out, and you're left with this side saying fx equals, and inverse g of 16 is what you get when you put 16 inside the inverse function. That's going to be 5 times 16 minus 4 over 16 plus 3. Okay, and that will give you f of x is equal to, that's going to be 80. That's 50 plus 30, 80 minus 76 over, and 16 plus 3 is 19. Okay, so 76 over 19 is going to give us, let's get the calculator. So we've got 76 over 19, which gives us 4. Okay, so we can see that f of x is equal to 4. Okay, we'll end up with having to solve the equation f of x equals 4. So if we solve f of x equals 4, we'll have found the answer. We'll have solved this equation. Okay, so would have solved this equation. F of x equals 4 solves this equation. And we can do that, and I'll show you how to do that. But I'm also going to show you a different method, okay, of doing what we just did. So I'm going to take the function and the inverse function. I'll just put this down here for now. Okay, there's another method which I think is actually nicer than the method that I just showed you. So you've got g f of x equals 16. And the inverse of g of x, which we said was, it was 5x minus 4 over x plus 3. Okay. So what we could do here, it's a nice little method, which one of my students by the name of Hamza Kundi actually came up with in a question where I gave a very similar question in one of my presentations, and he came up with this method which is really good. Okay, so basically what he did was this. I really like this method. He said, if we want to find g f of x, let's substitute the function f of x into g. And how would you do that? Well, you'd substitute it into this equation here, into this expression here. So gx equals g f of x. Just replace the x with f of x in this function. So you have 4 plus 3 times f of x over 5 minus f of x. Okay, and then it says g f of x equals 16. So make this whole thing equal 16. So we got now an equation 4 plus 3 times f of x over 5 minus f of x equals 16. And then we can solve this, multiply both sides by 5 minus f of x. So you have 4 plus 3 times f of x equals 16 times 5 is 80, minus, and 16 times minus f of x is minus 16 f of x. So we bring the f of x's together on one side. That's 3 f of x plus 16 f of x, which is 19 times f of x, equals 80 minus 4, which is 76. Just do that one step. 80 minus 4, which is 76. So we have f of x is equal to 76 over 19, which is the same thing that we got before. F of x equals 76 over 19, which is equal to 4. So we can say f of x is equal to 4. So when we solve f of x equals to 4, we have now solved the problem. So I've got to find out the values of x when f of x equals 4. What does that mean? Now we know that this is 5. We worked that out before. This is 5. So 4 is below 5. It's going to be over here somewhere. And we know that this is the point 6, 4. So we know one of the solutions is here. Okay. But there's another solution as well. So this is y equals 4. So f of x equals 4 is find x when y equals 4. Because f of x, remember, this is y equals f of x. So it's basically saying replace the y with 4 and find what x is. Okay, so you can see that you're going to get one solution here, okay, which is going to be when x equals 6. Okay, so one of the solutions to this is x equals 6. That's one solution. And the other solution is this value here of x. Okay, this value here of x, which is going to be down here. Okay, we have to find what that value is. There's another solution for x from this equation over here. Now we could find the equation of this line if we wanted to and find out what the x value when x is equal to 4, when y is equal to 4. We could do that if we wanted to. Or we could just use, again, similarity like we did before. So we have these two triangles. Okay, so we have this, you have a big triangle, which is, goes up to 5. Okay, you have a big triangle goes up to 5, just a bit neater. And you have a smaller triangle, okay, which goes up to 4. Okay, it goes up to 4, this one here. Okay, I'll take it from here. All right, now, the smaller triangle goes up to 4, and the bigger triangle goes up to 5. Okay, I know that this length here is 2. From there to there is 2. And I need to find what this length is. It will be the length here. And what I need is the x coordinate of this point, which is going to be 2 minus x. This is going to be 2 minus what I get in this part here. So what I need to find is 2 minus this value. So let's find what this value is using similarity. I know x, divided by 2 is equal to 4 divided by 5. So x is going to be 4 times 2, which is 8 over 5. And 8 over 5 is going to be, that's going to be 1 3/5, which is 1.6. That's 1.6. So our value, okay, is x. Let me call this x1, x. Our value x is going to be 2 minus 1.6, which is equal to 0.4. So our other solution is x equals 0.4. So we have both solutions of this equation. G f of x equals 16, x equals 6, and x equals 0.4. So that's the point 0.4 there, and that's the 0.6 here. When what we worked out, this is one way of working it out, where we want to solve this equation. So I thought, let's get rid of this g part by taking the inverse g of both sides. We already know what the inverse g of x is from the previous question. So if we take the inverse g of both sides, this negates this g part of this function, leaving you with what's inside the function, which is f of x. And on the other side, if you take inverse g of the other side, you've got to replace the x in the inverse function of g with 16. And we already found the inverse function in the last question, and that gave us 4. So f of x equals 4. So we got to draw the line y equals 4 and see where it hits this other function. And we can see it hits it when x equals 6. And that was given kind of because we know that that was a 0.64. And when y equals 4, we saw that by similarity we could work out what the coordinates of the other point are. So 0, 6, x equals 6, and x equals 0.4 are the two solutions from there. And the other method, which is the Hamza Kundi method, okay, where we basically had the original function, we replaced the x with f of x, because this is like saying it's basically replace the x in function g with f of x. That's what it's kind of telling you to do. So we did that, replace the x in function g with f of x, and then we equated that to 16. And then we solved for f of x, and we found f of x equals 4, which is exactly the same thing as we got there. And then when we drew the line y equals 4, we found it hits this function in two places. One is 6 and one is 0.4, which again we worked out through similarity. So there's the answer for this question. The last part of the question is a bit tricky, but it is doable. You have to just think a little bit, and some good thinking by some students does help to make it a bit easier. Okay, so I think this is like kind of a very understandable way of doing it, okay, which I personally didn't think of before this student mentioned it. But previously, this is the way that I was dealing with it, which is maybe a bit shorter. It is understandable as well, but this is more kind of like, I think, the more intuitive kind of way of doing it, like what you're used to, substituting something into the function. And it's a pretty cool way of doing it. So thank you very much, Mr. Hamza Kundi, for your contribution there. And I'd like to make you or guide you to the fact that this part of the video, I'm going to be putting a playlist for the rest of this paper. Once I get around to answering questions from this paper, they will be in that playlist. And questions about graphs and functions will be in the playlist that's mentioned over here, graphs and functions from P3. Okay, because now this C3 has become a P3 paper. You can subscribe to my channel from this place over here. And on the top of the page here, I will put a link, a card for maybe one of the past papers of P3 or C3 for something. And there you can maybe watch other things that might help you. Thank you for watching, and I'll see you again in another video.